Today I'm going to make a simple AI for my Pacman ghost. So they move around using ray casting to see which paths are available, which walls are missing, and they can go. And then I'm using the lerp function for smooth movement. With the C-frame, I'm using the new pivot to functionality. And I'm also using the collection service for junction nodes to see where they can turn because we're keeping them on 90-degree angles. I thought that'd be pretty cool. Let's go ahead and get started. I have an empty base plate right here, and I am going to delete the spawn location because I want to work in the center of the world. Now I'm going to add a part. Boom, there we go. And the part, I'm going to call this core. This is going to be the primary part of my ghost. I'm going to do my calculations and movement of the ghost based on this core part. So I'm going to resize it. It doesn't have to be a particular size, but I'm going to make it 1 by 1 by 1. And for position, oh, look at that. We put it right in the middle of the world. Let's make the position 0, 5, and 0. How about that? Let's try that out. So it's 5 studs high. That's pretty high, but we're going to make the ghost pretty big. I want to know the front of the core part. Sometimes I use a decal, but here I think it's just going to right click and then show orientation indicator. And that will show you which way the front of the part is. So the little F is connected to the front, and then the green arrow is the up. So this is oriented this direction. I'm looking right at the front of it. I'm going to need that for determining which direction my ghost is going to face when they're moving forward, when it's moving forward. Let's add like a head and then put an eye on there so we know which way it's going. So this is going to be the head. I'll just say head. And I'm going to put the core, I'm going to put the head so that it's centered over the core. So let me get my core part, and then I'll get the position, Control C, get the head part, make sure collisions are off, go to position, boom. All right. And we want to put an eye on there too, so we know what direction we're looking. Let's look down a little bit here. I'll add a cylinder. There we go. Let's call the cylinder eye. I'll just make a pupil. I'm not going to make a very complicated eye. I'm going to rotate this so that it's going to look like an eye on the front of my head. And then I'm going to resize it. Let's go to size. I think I'll make the eye 0.2 by 1.5 by 1.5. How does that? That looks good. Let's get it in the center of our head. So I'm going to get the head, and then I'm going to get the position, Control C. I'm going to get my eye, Control V. It's in the center of the head, but I need to pull it forward, but I don't want it to do that funny clicking so that it goes past the, see, that's the problem. It'll go out 10. So model temporarily. Let's change this to 1 stud increments. That'll work. Maybe just take move off and then move it in a little bit. How's that? That's pretty good. Turn move back on, go back to 10 stud increments. Let's make the eye, I'll just make it like the pupil, right? You make it like a dark color. There we go. That's pretty good. I can make this whole thing look like an eye. I like it. All right, we got to put everything together. So I'll just use a weld constraint. But first I'm going to make this into a model. So I hit core, control click head, control click eye, right click, group as model. And then I'll call this ghost. Right, open it back up. I'm going to put a weld constraint on the core. And then I'll connect the core to the head. So part 1 will be head. Part 0 will be core. Part 1 will be head. And then maybe another weld constraint. We could put it on the eye, right? And that one will be eye. Part 1 will be head. There, now it all sticks together. Also, the core, click the core. I am going to hit anchored because we're not using pathfinding, we're going to be using a lerp to move things. Now our ray casting is going to shoot out from the front, the back, the right, and the left to see if there's ways to go or if there's things of interest. So they're going to look for, the eye is going to look for either a junction node, a wall, or a character. Let's make the junction node first. So I'm not going to put it in my ghost. It's going to be part of my terrain. We can go to workspace here, hit the plus, add a part, and I'm going to make the junction node big enough so that if we're doing steering with our C-frames, we don't have to worry about any round off error. We don't want to make it tiny, right? So, and we'll turn can collide off and the transparency off, so it won't matter if it's kind of big. Let's find our part. Let's call this node, and I want to change the size of the node. We can make it like 5 by 5 by 5 maybe. There we go. And on the position, I'm going to make it the same as my core. So get the core position, Control C, go to your node, Control V, and now it's right in the center. It's not going to stay there though. My move and 10 stud increments is activated, and I'm going to move this out. 1, 2, 3. How about that? We can go ahead and put a tag on here. So I'm going to right click up here in the banner somewhere, hit my tag editor. I'm going to create a junction tag. So I'm going to call this junction. We don't really need junction tags because we could keep them all in a folder, but I'd rather do it this way just in case we have different types of junctions. So we'll go ahead and click that. Now it's tagged as a junction. We're going to want to anchor it. There's anchored. We're going to turn can collide off. This will be invisible, but I think for the sake of the video, let's make the transparency 0.8 so we can kind of see it, maybe 0.7. All right, now our ray cast will go out. It'll want to determine whether there's an enemy there or a Pacman, a wall, or a node. We'll work on nodes first. The other ones are really easy once you get that going. So let's make 4 nodes. If we could do a Control D and duplicate it, it's okay. The junction is gonna copy 2. That's pretty evenly spaced. Control D. Control D. There, we'll have them go around. And we might want to test right and left, but this method is going to work. You're not going to have to worry about it. We need to find our front. There's our eye. May as well put the nodes in a model. So I'll select all my nodes. I'll right click, group as model or folder, whichever you like. And I'm going to call this nodes. All right, let's go up to our ghost and add a script. Hit the plus, S for script. And there we go. We got a script. I'm going to call this patrol. Nice. I'm going to get rid of the tag editor for now so I have more space. All right, in order to set up our script, let's go ahead and get a variable for the ghost. So local ghost equals script.parent. And then I'm going to go and get a variable for the core. And that is the ghost.core. I need a variable for the collection service so I can get my junctions and my walls. We don't have walls yet, but we will. So game::get service collection service. And let's get our junctions, right? Junctions, collection service, get tagged. And we tag these as junctions. Those are our nodes, right? But we gave them a junctions tag. And walls, we don't have walls yet, but we will. That's fine. If we don't have anything tagged as wall yet, that'll just return an empty table. So we'll do walls here. Remember, we're going to have to tag our walls with the tag walls. All right, and then we need a filter list for our raycasting. I'm going to do an include list. So I'm going to say local include list. And right now, that's just going to be an open close parenthesis. Curly bracket, I'm sorry, open close curly brackets. These are curly brackets if you can't quite see it on the computer. And then I need a random number generator for picking the choice of direction. So I'll do rnd equals random dot new. Should we put a tick value in here for a seed? You can do that if you want. Now let's populate our include list. So I'll just do a for loop here for I and V in pairs. We'll get the junctions, do, table insert, and I get my include list. That's the table that I'm including things into, and the V is the object. I'm going to do almost identical for the table, right? So this will be not for the table, for the walls. This will be walls, and everything else looks good. All right, so we have tables and walls in our include list for our raycasting. Let's make a function for our raycasting. Let's make it local. Do local function. Local function, raycast. And we'll have P1 for 0.1, P2 for 0.2, and we don't need a distance. We'll use the newer raycasting. The old raycasting, you needed a distance. All right, we're going to set up our parameters for our raycasting. Params equal raycast params dot new, and then we'll get our params filter type enum dot raycast filter type include. What else? Params filter descendant instances. Oh, there it is. Include list. All right, so we're going to only get stuff that is included in our include list in our raycast. That's the only thing that's going to return a legitimate hit. So now let's go ahead and do the cast. I'll set as a variable for the result equals workspace colon raycast P1 to P2 pass the params. All right, so if we get a result, then let me center this a little more. There we go. We want to get the part of the result. So we'll do result.instance, right? And if CS has tag part junction, so if the part has the junction tag, then we're going to do a move, right? And you can check to see if it's a character, if it's a wall, things that you want to do. If it's a wall, we're just not going to do anything. It's going to stop the ray, but it's not going to return the result back to our loop. We're only going to take action right now on the junctions. So then I'll return the result instance, which is the part. We could just do part right here. And another thing we can do, let's do an else so we know if nothing hit. We'll do else print no result. There we go. So we're returning a part if we get something. We're not doing a return statement. If we don't get anything, that's fine. The function will default with a nil return. All right, now what do we got to do? Let's get our loop going and get some choices fired off. Let's wait 5 seconds to join the game before we start our loop. I'm going to do a while true do. And then I'm going to make a table for the choices that we have. We could go either front, right, left, or back. Right? Open and close curly bracket. It's going to be an empty array. Let's just move this up some more. And I will look front first. So let's see if we can go front. we'll do a ray cast, and we're going to get our core position as the start point. We're going to get the core C-frame. Oh, we should do the pivot to on this one. That's fine though. Core.C-frame dot look vector, and I don't know, let's go 200 studs out. You want to make sure that you can get to the end of the longest corridor in your maze though. All right, and then we'll say if the front, then table.insert choices. Oh, we want an S on there. Choices front. So that's all we're going to need. We're going to do this for every direction, right? So let's copy this, Control C, Control V. We'll do one for back, and back will be negative. Control C, Control V. We're going to do one for right and one for left. Control C. This will be right. And we're not going to use look vector. We're going to use right vector. We want this to be a positive number. All right. And then this will be right. And we're going to do one. Oh, this will be right too. Don't forget any. That's all right. I mean, you'll start noticing if it's not going left, you'll be like, I must have missed something. You'll actually probably notice it by a nil because you'll find a right, but if this is like says front or something, you don't have a front, you'll get a nil. All right, we'll do one more. That's for left. And left is negative right. Let's get our left, Control C, Control V, Control V. Now down here, we're going to have 4 choices, right? And if you want to weight the choices like, hey, let's take front over back, you can actually weight it by just giving it the choice twice. Now you're going to have twice as many fronts as you did before in your choices array, right? And then you might want to play around with those numbers for the weighting. When I mean weighting, you're more inclined to pick one thing rather than another. All right, so we get down here, and it really would be nice to visualize our rays. So let's do that really quick. Let's go to our base plate, and then on the core, I'm going to add an attachment. I'm going to call that ATT0. I'll duplicate it, Control D. I'll call this one ATT1. Oh, if I can get it, there we go. 1. And then I'm going to add a beam. This is only for testing. I'm going to get the beam, and I'm just going to take this attachment 0 from the beam, ATT0, attachment 1, ATT1, and then with ATT1 selected, this is what's going to happen. Oh, what did I just hit? Oh, I got it. Good. Hit this, move, get our ATT1. We're going to push it out so that we can see our ray cast, right? Because you can't normally see a ray cast. It's invisible. Let's hit a Control Z to move it back. We're going to do that with code depending on the choice we make, right? So if we get down here, let's do a local IDX. That's going to be the index in our choices array. We'll do a random next integer 1 to the number of choices. I keep doing that with an S. Let's move our ATT1 out that's on the core to our choice position. So I'll say core.ATT1 world position will equal choices open bracket IDX. And we could do the position and see what we got, right? Oh, and then let's do a wait. So we'll hold it for like 3 seconds. We won't do that in the production code, but we want to see we want to see the beam go out. Before I test this, there's one thing that I always do. Oh, and I did it here. So for my tags, junction. And then this is the collection of junctions. Same with walls. All right, so get tagged at the top on the variables. Change that to junction, change that to wall. Let's just make sure these are spelled right. Tag editor, junction. All right, cool. All right, let's play this. I don't need this here. Let's hit the play button, view, output. And there we go. We landed on our eye. Oh, look at that. It shot a beam out because it found the front. And eventually it'll switch to the back, right? So we have a 2-to-1 ratio of which way it'll select. And it's holding it every 3 seconds. But it's not going right and left because there's no junctions to the right and left. Cool beans. Now what we got to do is get that eye moving towards the junction, or if it's not facing it, but we want to turn to the junction and then move toward it. Let's turn this thing off and get back to our code. There we go. Patrol. I am in my patrol script, and let's go down below our for loops, perhaps above the raycast. And I'm going to make a function, local function, move to next point. We're going to pass in the part, which is actually going to be the core. And then I'm going to need a target position that we want to get to. I'm going to get the distance, the position distance that we have to move. So POS difference, we'll say target position minus part dot position. So that's the position difference. And then we'll get the distance from the position difference. Let's just call it dist. Using the magnitude, right? Because position difference is actually an X, Y, and Z value. A magnitude will make it a scalar, a single number. Now, I want to get a C frame, so I'll do C frame 1. I'm going to get the part C frame. This is going to be the start C frame, right? I'm going to use the new get pivot, right? Essentially, it's just part.C frame, but they say use get pivot, but you have to spell it right with an O. There we go. And then we'll do a C frame 2. This is where we want to go to, so we have to make a new one. So we'll do a C frame new, and then we'll get our C frame 1 position. That's where the C frame will be positioned at. And then the where it's facing will be the target position. And then we're going to move it the position difference, right? So that's the destination C frame. And then we're going to need a step function for our for loop. And the step function, I'll make 1 over dist. Now let's do our for loop. So for I equals 0 to 1 in steps of step, right? There we go. Now we'll get the part pivot to, setting the C frame, our CF1 lerp. Oh, it's a lowercase. Lerp. Linear interpolation. That's what lerp means. I like lerp because you can use it in Unity too. It's much more universal than the tween. So we're going to lerp to our CF2 in steps of I, which is step, right? And now we'll just do a short wait here. If we want to increase the speed between the 2 points, we will increase that number right there. All right, let's see if we can move. Let's go ahead and copy this, Control C. We're going to go down to our loop. And should we show this? Yeah, let's show that. But we get rid of our wait, right? There we go. We'll do our move to next point. This is going to be the core of the ghost. Target position is going to be one of the choices we picked. So we'll say choices, IDX, the index, and now we need the position of the index. Let's just do a check real quick here though. Make sure we're getting a choice. Make sure that the ray is actually hitting something. I'm going to do And if number of choices is greater than 0, then else we'll wait and cast again. Let's format our document. Boom. That way we make sure we have a choice before we try and move. Else we'll get an error. So I'm going to hit my play button. There we go. Oh, look at that. That's going pretty good. Are we getting any errors? Nope. But we have to do the facing, right? The facing isn't looking right. Let's do that. I'll get rid of my output window. I'm going to move up to where we have move to next point. Right above there, I'm going to do a function, local function face next point. And I'll get my part, which is the core, and then I'll get the target position. Very similar, right? And then let's do a CF1 part colon get pivot. And then that's a CR. Let's make that CF1. And then we'll do a local CF2. We're going to make a new C-frame, C-frame new. And then we'll use CF1, oh my gosh, CF1 dot position. We're going to go to target position. We're not going to do anything if we're facing the right direction, right? Sometimes we're going to go straight through a node if we don't want to turn. So let's do a check real quick. We'll say if CF1 dot look vector minus CF2 dot look vector dot magnitude, the difference between those look vectors, let's say is less than 0.1, we'll just set the parts pivot to CF2, right? And then we'll return. We didn't have to do any turning. We were close enough looking in that direction where nobody will notice. And if we get to here, we do have to turn. So I'll say for I equals 0 to 1, and I'm going to make this steps of 0.2 do part colon pivot to CF1 lerp to CF2 in steps of I. And we'll put the default weight there. At the end here, what I'm going to do is have a part pivot to CF2. So this is supposed to get us exactly to CF2, but there could be round off error. Hey, let's just make sure we are exactly at CF2 right here. Now let's go ahead and call this. Let's get our face next point. We're going to scroll down. Oh, and I see a mistake. When we were doing our cutting and pasting, so this is if the raycast goes front, I did a cut and paste there. Down here on line 69, back, right? Back. We didn't run into the error, but we could. Let's go on down. And this beam isn't really turning on and off at the proper time, so I'm going to delete it. We don't need it anymore. I'm going to do a Control V, face next point. This is going to be core. This is going to be our choices index position. Control C, Control V, and play it. Test it out. Yeah, looking good. The turn's looking good. Now let's put a couple walls up, and I'll put some more junction nodes so we can see if we can navigate the maze. Let's turn our game off. And we'll go to our base plate. Let's get a few more of these nodes. So I'll do an Alt click because it's in a model. Alt Control click. Do a Control D. And we'll make a few more of these nodes. Let's see here. That'll work. And maybe another Control D. Pretty wide maze, I guess. Control D, Control D. And now let's get a couple walls in place. I'll get a part. Where to go? There it is. Call this wall. Let's make it bigger. Scale it out. Anchor it. Cool. That's a pretty big wall. Let's make it smaller because it's going to be hard to see over. There we go. All right, we need to tag it. Right click. Tag editor. Got to make a tag. Wall. Click on that. Click on the wall. And now it's tagged. Let's make a couple walls to make sure we're getting some turns in there. Let's go ahead and duplicate that. Control D. Did I get it? I don't think I did. I did not. Control D. Let's grab that. Maybe move it over this way. I know I'm not making a great maze, but it will work for our testing. And maybe pull this here. How about that? All right. Another thing I'm going to do is I'm going to make it so the Pacman or my little eye doesn't want to go back. So we're going to weight it towards front or left, right movement. I'm going to do it very simply. I'm going to go to my patrol and I'm going to go up where we do our ray casting. And if we have something like front, let's make sure that we have several front choices in our random selection. Should we do 5, 6? Let's do 6. Back, we only want to have 1, right? We don't want to go back unless we really have to or occasionally. So let's do 2, 3, 4, 5, 6 for the right. And we'll do Control C. 2, 3, 4, 5, 6 for the left. Let's test this out. It will still go back sometimes, but it's going to go back less than it goes front, right, or left. See if we can ride it. That'd be cool. There we go. It went back. And it went right. So it looks like it's doing pretty good. Let's see if it shoots down this direction. Yeah, there we go. We got it going through a node. And it didn't pause to do any turning stuff. That's pretty good. Put a damage script on that and you have a Pacman ghost.